Hello and welcome to PSIRDEMATICA. In this video, we'll be looking at some basic terminologies associated with the use of Linux. So we'll look at some terminologies we would have to understand while using the Linux operating system. So without wasting much time, let's learn Linux. So for this particular video, we'll look at the components of Linux into details, look at what the shell is, what the shell types are, and then what do we mean by a process, and look at some other terminologies associated with the terminal and then the command line. Now, so we said that the Linux operating system comprises of 4 main parts in the previous video. So if you don't know, or if you not watched the previous video, you can go and then watch it. And the first one was the kernel, right? And then we said that the kernel is the core of the Linux operating system. So basically, it's the core of the Linux operating system. It sits between the hardware and the software. So it's a layer between the hardware and the software component of the system or of the machine. Now, this kernel receives tasks from the shell and performs them. So it receives some commands from the shell and then performs them or executes these commands. So basically that's what the shell does. And then it also controls the hardware and software on a computer system. So the kernel is also responsible for managing the hardware and then the software on the computer system. Now the kernel is responsible for 4 main functions, right? So that's the system memory management. So what the kernel does is that it looks at the memory that the system currently has and then how to allocate some processes or some programs to memory to create more space in memory by probably using the swap space of the hard disk to make the memory bigger and then thereby creating a virtual memory and then managing. So once the process ends, it then removes that process from memory and it makes the memory available for other processes back and forth. So basically the kernel is responsible for that. It also manages programs or software program management. So the kernel is also responsible for the software program management in the sense that it tries to know which programs to run after which. So that's a process. So first it initializes or it starts or it runs the init process or init program and then which then gives it ways to run other programs, so other processes. So the first thing is that probably it launches the interface and then knows which program to launch after which and then how to close or off or even shut down the system. So the kernel is responsible for that. And then hardware management. So now this hardware management comes in when you connect external drives or other external hardware. So like keyboard, mouse, modem and everything. The kernel incorporates the driver of this hardware into itself and then which enables you to make use of these hardware components. So the kernel is also responsible for managing the hardware you connect to your system and then the file system management. So Linux operating system can support or supports all other file systems including its own file system which is done by the kernel, right? So what the kernel does is that it creates a virtual file system which makes it possible to convert any other file system like NTFS, that's for the Windows, or other file system, FAT32, and makes it possible for Linux users to access, copy from, or copy to those other file systems. So basically, that's what the kernel does. And then these 4 main things are very important in the operation of the Linux operating system. Okay, so the next thing is the GNU utilities, right? So the GNU utilities is just a collection of programs used to perform standard functions like the controlling of files and programs, right? And these utilities is created by or was incorporated using the GNU project. So from the previous video, we spoke about how Richard Stallman decided to started the GNU project to make an operating system is like Unix free and open source for everyone. So the softwares he was able to gather that was used in together with Linux Torvalds kernel is basically the GNU utility or contains the GNU utilities. So these core utilities, right? So one, some of the utilities are responsible for file handling, creation, deleting, and manipulating of files, right? Others are responsible for text manipulation, so how the text should appear, the formatting, and all those things. And then others are also responsible for process management. Bear in mind that these utilities are sets of programs. So for every utility you take, it contains lots of programs and the reader enable these processes to be done well. The next one we'll look at is the graphical desktop environment, right? So from the beginning, Linux came with just a text interface. There was no graphics, no clicking. You can't copy, you can't do anything. But then, as Microsoft Windows operating system came into the system and users get exposed or are used to it, they started demanding for a graphical user interface from this Linux operating system. So the developers decided to come together and design a graphical environment, right? But then this graphical environment, before we can have a graphical interface, right, we first have to look for a way to communicate with the video card of the system in it and the monitor. So the video card will then process these graphics and then send it to the monitor for the user to see. So in order to do that, these developers decided to write a software, the X Windows software, right? So this X Windows software is a low-level software or low-level application or a low-level program that communicates between the video card and the monitor. So the common types of X Windows software that is being used in the Linux niche is the x.org, right? So the x.org was the first and then has been used till the Wayland came. So the Wayland is more secured and then it's easy to maintain. So currently Wayland is being adopted by lots of Linux distributions. But then the graphical environment alone can't do much because the graphical environment, yes, enables you to see what is happening, but then it can help you to drag and drop, create shortcuts, create pictures, create icons and all those things. So we need, or there was a need for a desktop environment which will run on top of the graphical environment, right? So this desktop environment will enable us to drag and drop, copy, move files and see the mouse movement and all those things. So in order to do that, the developers brought the KDE Plasma desktop and then the GNOME desktop environment. But then after GNOME 2, the GNOME 3 had brought about a lot of controversies. Other people wanted to still keep the GNOME 2, so they decided to build more flavors of that. That's the cinnamon or the matte. So basically, these are the graphical desktop environment for the graphical Linux that we are seeing now, right? So, and then the last one components that we spoke about was the application software. So now the application software is basically any other software aside the operating system. So any other software that performs a specific task or a specific function which is not part of the system operation. So like memory management or allocation, and then ensuring that the system performs well and stuff. So basically, application softwares are more or less third-party softwares or applications that may not be shipped with the Linux distribution. So some of the application softwares come with the Linux distribution while others don't. So an example is web browsers. So softwares that help us to surf the internet, like the Chrome, Google Chrome, the Mozilla Firefox, and then Brave. So Google Chrome is a third party. It doesn't come with Linux, but then you can install it as a third party software. Firefox ships with most Linux distributions, so that one comes with Linux. So it's part of the Linux distribution depending on the distro you want. And then we have multimedia, so you could install VLC to play your videos or music properly. So it's also an application software which doesn't come with Linux distribution, which you'd have to install. And then we have the document handling like the LibreOffice and a whole lot. There are other types of application software. So all these 4 components put together make the Linux operating system. Okay, so now that we are done with the components of the Linux operating system, let's look at what the shell is, right? So the shell, looking at the diagram here, right? So we could see that the shell surrounds the kernel, right? So just like the fruit and then the nut, right? The fruit is a shell and then the nut is a kernel. So what is the shell? So the shell is the interface with which the user interacts with the kernel. So the interface, in order to interact with the kernel, in order to let the kernel process or perform other stuff, in order to incorporate the driver into the kernel, you have to pass through the shell, right? So if you're a user and you want to do that, you have to pass through the shell. So for instance, in Windows, we could look at the shell as the File Explorer or the Windows Explorer. So basically, that's the shell enables us to interact with the kernel. It is also known as a command line interpreter. So the shell interprets the commands that would be given it, the commands that we pass through the kernel. The shell interprets it and makes the kernel understand what we are or what we intend doing. So basically, that's what the shell is. Okay. Now looking at the shell types, we have the Bourne shell, which is the original Unix shell, but then we said Unix was expensive in our previous video. So the Bourne shell comes with the Unix shell, and then we have the Bash, right, which is the Born Again shell. So this shell is or was created by the same person, Born, but then this was originally created for the Linux operating system, and this is originally part of the GNU project, so it's part of the GNU utilitors, right? And then we have the C shell, and the C shell is modeled after the C programming language. We have the TC shell, which is the C shell but then has some modding improvements. And then we also have the Z shell, right? The Z shell is an advanced shell which includes features of both Bash shell, the T shell, the TC shell, the cron. It provides advanced programming interfaces. So basically, there are a whole lot more of shells, but then these are some types that we are covering in this video. Now, let's look at the terminal. The terminal. So looking at this image here, we could just see that this is something that looks like our monitor in the current world in which we live in, and then there's a keyboard-like substance here, and we can see a screen full of text here. Yes, so basically that's the terminal, and the earlier Linux users only get this. You can access your operating system through a terminal, so you have a text output. That's when you put the shell commands as text, and then you get the outputs as text. That's all. So everything you want to do, you interact with your operating system through the terminal. You send text commands and then you get your output as text. There is nothing you can't use mouse, you can't use any drag and drop. There is nothing. You access it through the terminal. And this feature made Unix top-notch because it was lightweight and fast, very fast, since all the system memory is being used for the processes. There was no graphical interface that was making use of the memory unnecessarily, right? But then as the graphical desktops came into play, right, these graphics also needed to use some part of the memory, right? So some part of the memory was being used to render the graphics, the graphical interface of the Linux, which means that the runtime or the time it would take for the Linux to perform some processes becomes slower. So Linux become a bit slower, which wasn't much different from the other operating systems. So that was a bit of disadvantage. But at the modern Linux distros that we have that included the graphical Linux interfaces, right, also incorporates or came with some console or the terminal like version that came, right? So they had a virtual console, which means that for any Linux distro that you are currently using, you could still access your virtual console, and then it also comes with a graphical terminal emulator. So there's a virtual console and then a graphical terminal emulator. So before then, let's go and then look at a sample. So here I could access the Linux console of my Ubuntu system, right? Here. So it looks a bit like this. All I have to do is insert your username. To access yours, you would have to type or press Control Alt and then F2, F3, F4, any of them. So if you do Control Alt F2, you can access it. Control Alt F3, you access a different version of the virtual console. So I'll input my password. So you first have to log in, right? And then with your username and then password, then you can access your virtual console. So it looks like this. I am accessing my Ubuntu virtual console through a network. That's a SSH. That's why it looks a little different. But basically, you see this writing, you see the welcome screen like that, and then basically you can perform some basic tasks. So let me clear the screen. So you can perform some basic tasks like TTY to see which type of console you are currently running. Mine is the third one. You may probably, if you use Control Alt F2, that will be the second one. Control Alt F3 will be the third one for you, right? And then I could also type who am I, and then you say I'm Sedem. Yes, your username might be different from mine, but basically that's that to show that this is a different terminal. So these are just the documents or files I have on my Ubuntu system, right? So that's that. Now, so basically that's for the console, virtual console. To look at the terminal itself, the terminal emulator, right? So I would have to launch the terminal emulator of the machine I'm currently on. That's the Chromebook I'm currently using. So now the terminal is ready. So let's try this one. If I do who am I, you see the Sedem. When I do TTY, is 0. So that's for the first terminal session of the Linux. I have the Chromebook I'm on. If I do ls, you see that here it has different content from the previous one. That's from the Ubuntu setup or the Ubuntu server. Alright, so basically that's that. So that's to tell you that there could be a virtual console. You could access your Ubuntu or your Linux system through a virtual console, or decide to use a graphical terminal emulator. Okay, so now what's a terminal emulator? So it's a graphical user interface window that serves as a command line interface. So we said that the shell is a command line interpreter, and the terminal is what the command line interface. So an interface for the shell that accepts shell commands. So the terminal emulator is a graphical window that serves as a command line interface that accepts shell commands, right? So it means that it contains the command prompt, right? That's a shell prompt. So in last time you saw set them at penguin, so and then the tilde with the dollar sign. So this is a command prompt. So while you have to wait for the prompt to come, right, before you can input any commands after the prompt, right? And then you could also see this one. The palm one shows that you are typing in commands as root or as a super user, while the dollar shows that is just a normal user, right? And then the command line is the space after. So where we typed in the commands, that line throughout is a space after the dollar or the pound symbol. So example of the graphical terminal emulators are there. You have the Xterm, you have the Terminator, you have the GNOME terminal. So that's the default terminal that ships with Linux distro. And then we have the Termox. So there are lots of terminals out there that you can download and then use, right? Those are terminal emulators. Keep that in mind. Now, let's talk about some shell commands, right? So shell commands are instructions that tell the system to perform some specific action. So the instruction, so we typed in who am I, right, in the terminal, and then it told us who or the current user that is using the terminal. So basically that's what the terminal is about. And then we also know that the shell commands vary with respect to the shell that is being used. So if you're using the born shell, if you're using the born again shell, there are different commands associated with each terminal or with each shell that is being used. And then shell commands, depending on the shell, may be case sensitive or not. So your shell commands may respect the who am I could be typed without it being lowercase or must be a lowercase. We would be looking at that in subsequent videos. And then bash commands are case sensitive, which means that if we had typed the who am I in caps, let's say for instance, let's do who I, right? We saw that who am I command not found. But when we do who am I in small letters, we saw that it told us that we are them. So bash commands are case sensitive. You should keep that in mind. But then the Z shell, the commands are case insensitive. So you should pay attention as to the type of shell we are using and the type of command we would have to input. Alright, so now let's talk about what a process is, because when we were talking about the kernel, I made mention of processes, manages hardware for processes and a whole lot of stuff. So let's look at what a process is. So a process, so basically almost everything in Linux is either a file or a process, right? So a process is just an executing program. So you launch a software or a program. While the program is executing, it becomes a process, right? So basically that's what a process is. And then every process has a unique process identifier, right? That's a PID. So this process identifier is used by the kernel while allocating probably memory space or the hardware that is supposed to use, or the process that must come after the particular process has been initiated or initialized. And then the processes may be short, so they may run for a short period of time and stop, or may run indefinitely while the system is still on. So a process that keeps your machine on will keep running while the machine is on until another process has been initiated to close the machine or terminate the machine or off the machine. Then it's run. Then the process or the initialized process that is supposed to on your machine can now stop running. Now the Linux kernel is responsible for organizing processes. So as we said earlier, the kernel will organize which process should come first, which should come later, which should come last, and when it should happen. So basically that's what a process is. And then what is a file, right? So a file is just a collection of data. So you have a data maybe full of numbers separated by commas. Once you save them, it becomes a file. Which type of file? Comma separated values file. You have a text, that's the data. You could also have such a file, right? Files are created by users using text editors or running compilers. So if you use your text editor, you open your text editor and you type anything inside, then you create a file. Because your text editor, type in Python commands, Python language, whatever. You have your Python file. You could open your text editor and input bash commands and save it. You have your bash script. You put C, and then once you compile it, after compilation, there is an output file that has been, or that will be produced. That's also a file. So after running compilers, you still get files in return. Now every file must have a unique name, right? So you should have a name. Every file should have a name. There is no file without a name. So you should give names to every file and make sure it's unique. Once you are creating them at the same place, give them unique name. And then every file has a path. So that's where to locate the file. So every file has a path. So we should always look for the path for files, which we'll be looking at in the subsequent videos. And then the file extension, right, are used to differentiate between the file types, which means that every file should have an extension. So if you have a text file, probably should end with txt. If you have a Python file, it should end with .py. If you have an Excel file, it should end with xml, whatever, and then a whole lot. So it means that every file extension will tell you the type of file it is, right? So basically that's the file extension, which means that it's advisable to associate or end your files with their file extension so you can know the type of file you are dealing with. Now, we can't talk about files without directories. So what are directories? So basically directories are containers where we keep files, right, and other directories. So on Windows, we call directories folders. So basically folders are what we call directories in Linux, right? And these directories contain or hold different file types, right? So it can contain any file type at all: movies, music, text, any file type at all. And it could also contain other directories, right? But then it is important to know that every directory has a path. So to access any container, any file container, you should know the path to that container. And then it should have a name, or it must have a unique name as well. Just like how files have their unique names, directories should also have their unique names. Now, talking about the directory hierarchy in Linux, we should know that if you see the /, right, it means root, the root directory. And this root directory is the mother of all directories. It contains all other directories in the Linux operating system, right? And then we have the /bin, and this contains binary files. So it's also called binaries. So the binary directory, right? And then this contains executable files. So the programs that you can run, right, you see them in the binary folder or the binary directory. They are the executable files. And then we have the /etc, which contains system configuration files. So the system configuration files are files used by your operating system to do other things, are found or can be found in the etc folder. Then we have the /home. The /home directory is responsible for keeping user data, so user specific data. So for instance, the user setting has its own home and has its own files and other stuff in it, and you could have another user pool which would have its different documents, folders and everything. And then the home will contain 2 or 4 directories depending on the number of users present on the Linux account or in the Linux system. Then we have the OPT, that's the /OPT, that keeps optional files or programs. So this is the optional directory, and it contains optional softwares such as the third-party application softwares we spoke about. So your Google Chrome that doesn't ship with the Linux distribution would be stored here in the /opt folder or directory. And other external software or application that you install later would be stored there. And then we have the temporary folder, and temporary directory stores temporary files. So files that are needed temporarily or that are used temporarily. And then this folder gets refreshed. So the contents of this folder get deleted after the system reboots. So if you keep any file here, you would lose it after the system reboots or restarts. So keep that in mind. And then we have the user folder or the user directory. And this user directory contains user related files, right? So if the user SEDEM has downloaded some programs that he wants to run, he would keep these directories inside the user or the files of the user would be kept inside the user directory. So basically that's that. And you also have the variable directory, which keeps variables, files or data that keeps changing while the system is being used. The /var directory keeps those files or those directories for us. So this is a diagram representing how the hierarchy is. You have the roots here, then the binary, the etc, the optional. Then we see that the home directory here contains two different users, right? The SEDEM user and then the SERDEMATICA user. So the SEDEM user, all the files of SEDEM would be kept here. The movies, the documents, the files, everything will be here for SEDEM user. And then the SERDEMATICA user would also have its own files. So while SEDEM logs in, SEDEM won't see the contents of SERDEMATICA or anything that has to do with SERDEMATICA. But while SERDEMATICA also logs in, he wouldn't see what SEDEM has in its home, right? So basically that's all about the hierarchy. There are a lot of other temporary ones like the boot and a whole lot, but basically this is the idea or the hierarchy that you should know and what they do in the Linux operating system. So this is a very long video. Yes, thank you for staying long till this time, but then it was important to take or get these terminologies out of the way. Up next, or in the next video, we'll be looking at the basic terminal commands. We'll look at some terminal commands that are necessary that we can use to make our lives easier and then help us navigate them faster. Thank you very much for joining us in this video. Please don't forget to like and subscribe and share with your friends so they could also learn as we learn. Thank you.